Imagine you're sitting in the testing center taking the RHCSA exam. You've just typed out what you believe is like a flawless, elegant command line pipeline.
Oh, I know this feeling.
Right. You hit enter, the terminal returns this beautifully clean prompt, and you walk out of the room feeling completely confident.
But you actually just failed the entire objective.
Exactly. You failed. And why? Because you missed a single uppercase letter.
Ouch.
And your system just silently dropped all of your meticulously sorted files into completely the wrong directory. So welcome to the deep dive.
Glad to be here.
Today, your mission is to master a really highly specific, high-stakes system administration scenario designed to help you pass the RHEL10 RHCSA EX200 exam.
That's a tough one.
It is. We are working from an independent RHCSA lab guide, specifically episode 32, which covers archive and regex parsing.
You know, the visual they chose for the cover art of this guide, it really tells you everything you need to know about the mindset required here.
Oh, the penguin.
Yeah, the penguin. It's a penguin wearing a tuxedo and a bow tie, just standing in the middle of a glowing server room.
And he's got a microphone in one flipper, right?
Right. A microphone, and in the other, a frosty cold soda. I mean, that penguin is completely unbothered by the pressure of a server room.
He's totally chilled out.
Exactly. And that cool, methodical state of mind is exactly what this material is trying to build for you.
I love that image, honestly, because memorizing a cheat sheet of commands, well, that won't save you when a server actually goes down. Knowing the why behind the command is your absolute superpower.
Yeah, without the why, you're just typing blindly.
So, okay, let's unpack this. Before we start throwing syntax at a terminal, we have to understand the real-world operational problem we are trying to solve here.
Right, the scenario.
The scenario is that a legacy application running on your server is misbehaving badly. It's spewing entirely unstructured debug logs into a shared directory.
Oh, I've lived this nightmare. I once spent, like 3 days hunting down a memory leak, only to realize the ohm killer was quietly assassinating my database in the background.
The ohm killer, that's brutal.
It is. Seeing fatal loom, which, stands for out of memory, it gives me actual physical anxiety.
I can imagine.
And that is your exact objective in this scenario. You need to parse through a messy directory, find only the specific log files containing that fatal loom error, and compress them into a tarball archive.
And then hand them off to a newly created functional user named Backup Manager.
Yep, that's the one.
But handing off the file isn't the tricky part. The absolute most crucial requirement of the objective is that the archive you create must retain its exact original directory structure.
This is where people mess up.
Right. Because when the engineering team takes your archive to a sandbox environment later, they need to extract it safely and see exactly where those files lived on the original system.
It has to be a perfect mirror.
Yeah, so this entire objective is basically a hidden trap revolving around absolute paths versus relative paths.
It really is. The default behavior of the tools we use every day, they're designed to protect us. But in this specific exam scenario, that protection is the exact thing that will cause you to fail.
Because of how tar handles the paths.
Exactly. By default, when you use the tar command to compress files using absolute paths, meaning paths that start at the very root of the file system, with that leading forward slash, like varlog legacy app tar automatically strips that leading slash away.
It just silently removes it,
Yeah.
changing it to just varlog legacy app without the slash.
Right. And it does this for system safety. Like, if someone sends you an archive containing heavily modified system files and you blindly extract it, tar prevents those files from automatically overwriting your own computer's critical root directories.
Like your setter pass rad file or something.
Exactly. It drops the extracted files locally right wherever your terminal is currently parked.
Which is a brilliant safety feature for daily life, but, I mean, a total disaster for this exam objective.
Total disaster.
Think of it like packing a box for a cross-country move. If you don't use a highly specific label on that box like 123 Main Street kitchen upper left cabinet, the movers are just going to dump all your spatulas and coffee mugs on the front lawn of whatever random address they happen to be parked at.
Yeah, they just open the truck and dump it.
Right. Preserving the absolute path is the ultimate moving label. It guarantees your files end up exactly in the right structural location when unpacked, no matter where the engineer is standing when they run the extraction command.
And if you let tar strip that leading slash, the automated grading script on exam day will check the structure of your extracted archive, see that the absolute path is missing, and instantly mark the task as a failure.
Instant fail. So Since practicing this absolute path, archiving on a live production server, could accidentally overwrite critical system files if we mess up the moving labels, we need a quarantined area.
A safe space to fail.
Exactly. How do we build a sandbox that safely mimics this exact disaster without risking the host system?
Well, we have to replicate the exam scenario from scratch, executing all of these setup steps as the root user.
Okay, as root. Got it.
The first step the source material gives us is a command chain to silently verify that the tar utility is installed and install it if it's missing. It's rpm-q tar devnull dnf install-y tar.
Okay, let me break down the logic of that chain, because it is a masterclass in defensive scripting.
It really is elegant.
Right. So rpm-q tar simply asks the system if the package is installed. But we are sending that output to devnull, which is essentially a black hole in Linux. We don't want the terminal cluttered with the answer.
We just want the background result.
Exactly.
Yeah.
We only care about the double pipe symbol there, the two vertical lines, which acts as a logical OR.
And that logical OR operator relies entirely on exit codes, which are invisible numbers the system passes back after a command runs.
Like a secret handshake.
Yeah, exactly.
Yeah.
If RPM finds the tool, it sends a successful 0 code in the background and the system stops looking. The chain is complete.
But if it fails...
If it fails, it throws a non-zero error code. And that error code triggers the second half of our trap, the DNF install command, which goes out and actively fetches the package.
It ensures tool availability before you even begin the real work. It's so smart. Next, we need the target functional user who will eventually own these logs. We use user-add-backup-manager.
Which is great practice anyway.
It is, because it satisfies a secondary domain objective of the exam creating and modifying users.
Yeah, 2 birds, 1 stone. So with the user ready, we need to build the directory structure for our haystack. The lab uses Enmity Verlo Legacy app.
Okay, the bit of P flag.
Yeah, the B flag stands for parent, and it is crucial for creating idempotent scripts.
I love the AV flag because it is so forgiving. Like if the varlog directory didn't exist for some reason, the very P flag tells the system to just quietly create any missing parent directories along the way.
No messy error messages?
None. Just seamless creation. So now we need to populate that directory with messy logs.
Right. The source material uses the echo command to write specific strings into 4 different text files, app-01.log through app04.log.
Setting up the dummy data.
Exactly. The first log gets info, system started normally. The second gets our target, fatalum, memory limit exceeded at 0x00A.
Okay, there's our first needle.
Yep. The third gets warn, high CPU usage detected, and the fourth gets another target. Fatalum, memory limit exceeded at 0x1 F4.
Wait, okay, I have to push back on this step.
Oh, what's the issue?
Why are we taking the time to generate fake info and warn logs if we only care about the fatalum errors? Like, if we are just practicing the archiving command, why not just create the 2 error logs and move on? Isn't this just extra busy work?
I get why you'd think that, but no. Simulating the noise of a real production environment is the only way to test if your parsing tools actually work.
Oh, because otherwise it's too easy.
Right. If you only put the target files in your sandbox, you aren't testing your regular expressions. You are just writing a command that grabs everything in the folder.
I see.
Your regular expressions need a haystack to prove they can accurately find the needle. If you don't have benign logs to ignore, you can't verify that your filter discriminates correctly.
Okay, that makes total sense. You have to prove the tool ignores the false positives.
Exactly.
So we have a directory populated with a mix of benign information, warnings, and our critical target errors. How do we surgically extract just the failures? Because we aren't just looking for the word fatalum.
Right. The addresses change.
Yeah, in a real system, the memory addresses at the end of those errors, like 0x0a0a or 0a1f4, are going to be completely dynamic.
And this is where regular expressions, or regex, elevate you from a beginner to a true systems administrator. The lab doesn't just use a simple string search. We use the grep command with the E flag, which stands for extended regular expression.
Okay, hit me with the regex.
We tell grep to look for fatalum.0x0-9af plus E.
Okay, that string of characters looks like someone literally fell asleep on their keyboard.
It always does it first.
Let's translate that regex into plain English, starting from the left. We have the literal string fatalum. That part is easy. But then we have a dot and an asterisk.
So in regex, a dot means any single character. It could be a space, a colon, a letter, anything.
And the asterisk.
The asterisk immediately following it means 0 or more times. So you mean tells the search engine, after you find Fatalum, I don't care what characters come next or how many there are, just keep scanning until you hit the next specific pattern.
And the next specific pattern we define is 0x, which is the literal text prefix used to denote a hexadecimal memory address.
You got it.
So we find Fatalum, ignore the filler text in the middle, and look for 0x. Then we hit the brackets, 09AF plus Djere.
Brackets define a character class. We are telling grep that the next character must be a number between 0 and 9, or an uppercase letter between A and F.
Because those are the valid characters in hexadecimal code.
Exactly. And finally, the plus sign plus at the very end means one or more of the preceding class. We are capturing the entire memory address no matter how long it is.
That is incredibly powerful. We aren't just looking for a static word. We are creating a flexible, dynamic net that catches the exact shape of the error, regardless of the specific memory address that caused it.
It's a beautiful thing when it works. And now that we have our regex net, we deploy it as part of the core implementation. The lab solves this entire complex scenario with a single bulletproof one-liner.
Here's where it gets really interesting.
It looks like this. grep-rlle fatalum.0x0-9af plus varlog legacy app zargs tar-czpf home backup-managedroom-logs.tar.gz.
Wow. There is an immense amount of Unix philosophy packed into that one pipeline. We already covered the E flag for extended regex, but grep is also using S, R, and L.
Right.
The F4 searches recursively through the directory, but that lowercase L flag is doing some very heavy lifting here.
Huge heavy lifting. If you omit the L flag, grep will find the matches and output the actual text of the log file to your screen. It will spit out Fatalum, memory limit exceeded at 0x00A.
Which is useless for archiving.
Completely useless. Because the archiving tool, tar, doesn't care about the text to the error. It needs to know the name of the file that contains the error.
Oh, I see.
Yeah, using arrow, you aren't just cleaning up the visual output. You are fundamentally changing the data type you are passing down the pipe. You are converting raw text strings into actionable system objects, the file paths themselves.
So the output becomes a clean list.
Yeah.
Varlo legacy -apphab 02.log and app-oe4.log. Then we hit the pipe symbol tar, which takes that list and passes it to the next command.
Zargs.
Yes, Zargs. I always think of Zargs as a specialized diplomatic translator. It solves a massive communication breakdown between Linux commands.
That's a great way to put it. And that communication breakdown comes down to standard output versus standard arguments.
Right.
Grep speaks one language. It is essentially just shouting that list of file paths into the terminal's standard output stream. But tar, the tool we need to use next, is deaf to standard output when it comes to deciding which files to compress.
It's expecting something else.
It expects direct arguments. It expects you to explicitly type the file names at the very end of the command line.
And Zargs sits right in the middle of that conflict. It
Yeah.
listens to the standard output from grep, writes those file paths down on a metaphorical clipboard, and then hands them directly to tar as appended arguments.
It translates the data stream perfectly.
Yeah, so tar can actually understand the instructions and act on them. Without Zargs, tar would open up, look around for files to compress, see nothing provided as an argument, and just fail.
Exactly. So with Zargs feeding the file list perfectly, we arrive at our archiving command, tar-czpf.
Okay, I understand the Zarg is to create a new archive, and the Zarg applies gzip compression to shrink the file size.
Yep, standard stuff so far.
I also know deva trips people up because it specifies the file name, meaning you must immediately provide the destination file right after it. In our case, home backup-managedroom-logs.tar.gz.
Yeah, if you mix up the order and put the netf before the z, the command shatters.
Totally breaks. But we skipped the most important letter in this entire deep dive.
The capital -P flag.
The ultimate moving label we talked about earlier.
This is it. What's fascinating here is that this is the flag that overrides tar's default safety mechanism. It forces tar to preserve the absolute paths.
It forces the issues.
You are explicitly telling the tool, do not strip the leading slash from these file paths. I know the security risks, but I want the exact directory structure hard-coded into this archive.
And forgetting the capital P means the archive extracts locally relative to your current working directory.
Which, as we know, results in an instant fail on the exam.
Heartbreaking. So once the tarball is created, we have an artifact sitting in this system. But because we ran all these commands as the root user, the resulting archive is currently owned by root. The scenario strictly dictates it must belong to the functional user.
We resolve that quickly using the chown command. Chown backup-manager, .backup-manager, home backup-manager, and logstot.tar.gz.
Ah, the user.group format.
Yes, that format securely transfers both user and group ownership of the file to the target account, satisfying the final requirement of the handoff.
So we've built the sandbox, we've run our bulletproof one-liner, and we've changed the ownership. On paper, we are done.
On paper, yeah.
But on a certification exam or in a high-stakes server room during a crisis, you don't just walk away hoping a command worked.
Never.
You have to prove it. You have to verify your success without accidentally breaking the archive or the delicate environment you just carefully curated.
Verification is the absolute mark of a professional administrator. The source material outlines a specific non-destructive test. We use the tar command again, but this time with the AST flag, which lists the contents of the archive without unpacking it.
Okay, just a list.
Right. tar-etf home backup nash-manageroom-logs.tar.gz. We pipe that output into head nash n2, which simply limits the terminal output to the first 2 lines so we aren't overwhelmed by text if the archive happens to contain thousands of files.
Now, I can hear people listening asking, why not just extract the archive to see if it worked? Seeing is believing, right? Why are we just reading a text list of contents?
Premature extraction is incredibly dangerous. If you extract the archive while you are standing in the wrong directory, you might overwrite existing system files.
Oh, because we force the absolute paths.
Exactly. Even worse, on an exam, you might alter the current working directory, creating a sprawling mess of folders that you now have to clean up. The automated grading scripts look for unauthorized leftover files, and leaving behind unintended trash can cost you points.
So you must use a non-destructive test.
Yes. Listing the contents proves the structure is correct without altering a single byte of the file system.
So what does this all mean? When we run that non-destructive list command, what we're actually looking for is visual confirmation. We expect to see varlog legacy-app-02.log. We are looking specifically to see if that leading slash is present at the very beginning of the line.
The proof is in the slash.
Right. If it is there, it proves our "P" flag worked perfectly. The moving label is intact.
And once verified, we execute the comprehensive cleanup, which the source material refers to as zero trace.
Cleaning up the sandbox.
We recursively remove the entire log directory we created for our sandbox using rnrf varlog legacy app. Then we delete the functional user and their home directory using userdel rhr backup manager.
Leaving the system exactly as we found it, but walking away with the knowledge of how to execute the maneuver flawlessly, it brings me right back to the cover art for this lab.
The penguin.
Yeah, that tuxedo-clad penguin holding a cold soda in the server room isn't panicked about the legacy application crashing. He is cool under pressure because he understands the unseen mechanics of standard output versus arguments. He leverages Regex to filter out the noise, and he verifies his work non-destructively before moving on.
If we connect this to the bigger picture, system administration at this level isn't about memorization, it is about methodology. Every single piece of that pipeline, from the exit codes validating our tools, to the grep data conversion, to the zargs translation, has to work in perfect harmony.
Let's quickly summarize what we accomplished today. We tackled a notoriously tricky RHCSA archiving scenario. We learned how to build dynamic regex nets to catch variable memory addresses.
Crucial skill.
We learned how grep uses the LL flag to isolate system objects instead of raw text. We learned how zargs bridges the communication gap to feed those file paths into tar. And we discovered that the "P" flag is the crucial difference between preserving an operational directory structure and suffering an instant exam failure.
When you combine these tools, you aren't just reacting to a server alert, you are commanding the operating system at a structural level.
You really are. But I want to leave you with a final thought to mull over, something that builds on exactly what we've covered today. We use this grep to zargs to tar pipeline to isolate fatal in-memory errors as a troubleshooting exercise.
Standard maintenance.
Right. But consider this. What if, instead of an out-of-memory error, you were parsing massive, terabyte-sized system logs for unauthorized access tokens, or looking for the specific variable signatures of a security breach?
Oh, wow. That changes the context entirely from basic maintenance to active defense.
It does. This exact same methodology, finding specific strings with dynamic regular expressions, isolating the compromised files, and securely archiving them with their absolute paths completely intact, isn't just a parlor trick to pass a certification exam.
Far from it.
It is the foundational blueprint for digital forensics and automated incident response. When a system breach happens, you have to preserve the evidence exactly as it existed on the disk for the security team to analyze later.
You need that pristine snapshot.
Yes, mastering these essential tools doesn't just make you a certified administrator, it makes you a system survivor. The next time you sit down at a terminal, remember, you aren't just typing commands. You are writing the exact moving labels that dictate how your data survives the transition. Make sure you don't drop it on the lawn.